Alright folks, so this is our planer, also known as a surfacer. What this machine does is it will take the surface of a board and go over it and make it thinner. Okay? When we cut trees down at a sawmill, alright, we get boards like this, right off the tree, right? You can still see the bark, and you can see how very rough the surface is. So the job of this machine is to pull the boards through and get rid of this rough surface and smooth it out, and take it to the correct thickness you want. Okay? Some of the parts of this machine are, this big table is called a bed. Alright, this moves up and down by moving this hand wheel on the side. Okay, and it's hard to see where you guys are at, but it's labeled down and up with an arrow, so you can tell which way you're going. Okay? There's this handle right here. So let's say if the bed was all the way down and you have to move it all the way up, instead of turning this hand wheel several times, you could simply lift this power feed up while the machine's running, and it'll automatically spin this wheel to move the bed where you want it. Okay? Across the front of the machine, there's a scale. Alright, this machine was built in Brazil. So there's a regular English inch system at the bottom in red, and there's a metric system at the top in black. So which system do you think we're going to use? Okay, the English, the red system, the inches. Okay? We have our start-stop switches over here, okay, to start the machine. And right up top here, we have what's called a blast gate. All right, this needs to be pulled open, all right, before using the machine. That opens the air to the dust collector so we can pull all the sawdust away as we're using the planer. What do you guys think might happen if we forgot to open the blast gate and we start running this? It won't explode.
Sawdust could build up inside the machine.
Okay, this thing's going to basically start throwing, spitting out sawdust towards you. Right, so you're going to know pretty quick if you forget to open your blast gate. Okay? The way this works inside is under this cover is a big circular cutter head, about 24 inches long, with 4 24-inch long knives spinning around. Okay? In the front and in the back, there's 2 rollers. They're feed rollers. So what they do is they grab the board and pull it through the machine. So the machine automatically moves the board for you. You don't have to push it in. All right? Now, if we were to plane one of these boards, okay, let's say I've got this board and I'm going to measure the thickness. Right now it's about 15/16 of an inch thick. And let's say I want this to be a 1/2 inch thick. What would I set the bed for? 15/16, or do I set it for a 1/2 inch? Yes, sir. Okay, you would set it actually for what the board is. Because if we set it for a 1/2 inch, it's going to try and take all this material off in one pass, and it can't do that. So you always set it for whatever the measurement is first. Okay, so what I'm going to do is look at my ruler, and I'm going to turn this until we're at 15/16, which is right there. If I run this through right now, is it going to do anything? No, because it's at 15/16. So what I'm going to do is grab the hand wheel, like pretend this is a clock at 12 o'clock, and I'm going to move it a 1/2 turn up to 6 o'clock. So now it's going to take off a little bit of material. Does that make sense? All right, now, this machine has the potential to kick back, meaning, and I've never seen this happen, but it is possible that while the board is going through the machine, the board could shoot backwards towards the person using the machine. So would it be a good idea to stand directly behind the board? No. Okay, you always stand to the side of the board. The other thing is, you guys see how the bed here, there's a gap between the board and the table and the bed, right? What happens is when the feed rollers grab this board, it kind of pushes down on that board and starts pulling it in. So what do you think might happen if your finger was under that board? Okay, you're going to get pinched. It's called a pinch point. All right? Also, not only is it pinching your finger, but what's the machine trying to do? Yeah, it's trying to pull the board in. So it doesn't know if your finger's pinched there or not. It's going to try and pull your finger in with it. So you never want to have your fingers underneath where the pinch point is. Does that make sense? Okay. Now, there is some dimensions that we need to be aware of when we're going to use this. Across the top here, I have a 14-inch line drawn on the machine. That means that you have to have at least 14 inches in length for this board to go through, okay? There's no limit to how long it could be. You could go as far back as the wall, and we could open the back doors if we had to run a long board through. But what would happen, you think, if we had a board that's shorter than 14 inches? What might happen? Okay, it'll get stuck in the machine. If that does happen, what do you think you should do?
Turn it off.
Okay. Usually your first instinct would be to just turn it off. On a planer, the difference is if you just turn it off, the feed rollers are going to keep trying to push that board into the machine as it's slowing down. So the first thing you do is lower the bed and then turn the machine off. Does that make sense?
Mm-hmm.
Okay. So what we're going to do is I'm going to reset my measurement, give it a half a turn up, and we're going to run a board through. JP, if you would please turn on the dust collector. Okay, we're going to start it up. Okay, JP, turn it off. So you guys can see the board does not look much different, but if I take my ruler to the edge of the board, we were at 15/16, now we're at 7/8 of an inch. Okay? So now we've lost a little bit of material. If I wanted to get this to a ½ inch, I would keep turning, a half a turn. All right, you could go a little less, but never more than a half a turn. And then keep going and measuring until you get to a ½ inch. Okay? Now, I have a ruler on me, I have a tape measure on me. Let's say you don't feel like walking all the way to the tool cage to get a ruler, because it is a far walk, right? On the front of the machine here, there's this little shelf that you can set your piece on, and there's a red ruler right here. So you can use that ruler as well if you don't have a tape measure or a ruler. Okay, it'll work just the same. Questions so far? Okay, what I'd like to do is I'm going to have you guys all line up in a single file line. You'll come up, and every other person, because we're going to run 2 boards, will have to turn the hand wheel up a half a turn. Remind you if you have to or not. We'll run the board through, okay, and then you'll get back in line until everyone's gone through and used the machine. Run your, no, you don't have to turn it. Okay, first of all, you guys all did a great job on your first run here. A couple more things. You can see these 2 boards have lost a little bit of weight, and they're a little smaller now, right? Is there a minimum, you think, of how thin we could go with these? Yes?
Yes.
No? Yes? Okay, yeah, there is. When we get to about 1/4 of an inch, all right, we can still continue to plane it, but we have to change the way we do things. What we do is we get another piece of wood the same size or a little bit bigger called a jig or a backer board. All right, and what we do is place that underneath to add support, because as it gets thin, it gets weak. So if you put a thicker board underneath to help support it, then reset the thickness of the planer to the total thickness, run both boards through, now you can take that top board down to almost paper thin. Okay, but that's called a jig or backer board. You guys probably won't need to do that, but it's good information to know. All right, do you think it's ever a good idea while you're using this machine to kind of talk to somebody or look away? No, you always want to concentrate on what you're doing, right? All right, so let me just review a little bit. Does anybody remember what the minimum length is?
14.
Okay, 14 inches, very good. What is this big table called?
Bed.
Bed, yes. Which scale do we use?
English.
The English one, the red one, yes. Okay. What is this called over here that we move the bed with? What is it? Well, yeah, we pretend it's a clock, but it's a hand wheel, okay? So, if we want to cut something thinner, which direction do we go? Up or down? Up, very good, okay? Is there ever a time you would want to look directly into the machine?
No.
No, why?
Doesn't shoot out.
Okay, sawdust even, something could shoot back at you, get in your eye, whatever. Okay, is it a good idea, you think, to run your hand across here to wipe dust away?
No.
No. Okay. Let me make sure we covered everything else. Where should we stand? Always to the side, not directly behind the board, right? Okay. And what's the most you should ever turn the hand wheel? Half a turn. Very good. Half a turn. Okay, now, one thing we didn't cover yet. This all worked out well today, but occasionally a board will get stuck in the machine. All right? Did we talk about that yet?
Yes.
Okay, we did. All right, so just as a review then, what should we do when the board does get stuck?
Turn the head.
Okay, lower the bed first, and then what?
Turn it off.
Turn it off. Okay, great. Questions? All right, guys, we can go back to the benches and we'll get our safety tests out. Great job. All right, folks, this is our jointer, okay? Just some parts of the jointer before we get started on actually what it does. All right, there's an in-feed bed and an out-feed bed. Okay, this looks like one big long table, but in reality, there's two different beds that this in-feed side is just about 1/16 of an inch lower than the out-feed bed. Okay, and you'll see why in a minute here. This part right here is called the fence. All right, we have what the industry kind of terms a pork chop guard, basically because it looks like a pork chop. All right, but it is a guard that protects us from the cutter head, which is underneath. Okay, this is a very similar style cutter head as to what's on a planer, except obviously this is smaller. This one's 8 inches. The planer has a 24-inch cutter head. Okay, the cutter head spins this direction, and it's got 3 knives in it. Okay, that cut the edge of the board. All right, so does anyone know what the purpose of a joiner is? What is it actually designed to do? Yeah. Go ahead.
Smooth out the sides.
Okay, smooths the sides. What else?
Very clean surface for a joint two boards together.
Okay, for gluing edges together, you need a nice clean surface. Do you guys remember the board I showed you yesterday that was right from the sawmill and had those really rough edges and really rough surfaces? Okay, obviously when you cut a tree down, it doesn't have a perfect edge like this, right? So the jointer will be responsible for making not only a smooth edge, but perfectly straight, and also 90 degrees to the surface of the board. Okay, our fence is set right now at 90 degrees. It can be adjusted for anywhere from 90 to 45 degrees, depending on what type of project you're doing. Most of the time, we keep it set right at 90 degrees. Okay. Now, we talked yesterday with the planer about a minimum length the board needs to be. On the jointer, this needs to be a minimum of 12 inches. And I've painted a red stripe right across the fence. So if you're unsure if you have the correct length, you can just simply hold your board over the red stripe. If it's longer than the red stripe, you're good to go. Okay? What do you guys think could happen if we ran a board that was too short across the jointer?
It's not gonna cut.
What's that?
It's not gonna cut.
It'll cut. What could happen though?
It won't go all the way through.
It might not go all the way through, but chances are, because that board's so short, you don't have control of it, and it might kick back. The cutter head might grab it and throw it back towards you. All right, so you always make sure that the board is long enough. Now, yesterday we also talked about the grain direction. Which way did we run the grain going through the planer? Anyone remember? Okay, in the same direction that it goes into the machine, right? So it's the same thing with the jointer. We always run the grain in the same direction we're moving the board, okay? We never ever joint the end grain, meaning going across the lines in the wood. Anyone know why? Some of you have used the jointer before.
Split it.
Okay, it actually will split it. The fibers of the wood are very much like, if you guys imagine a bunch of drinking straws, okay? If you take a bunch of drinking straws in a group together and you ran your hand down the side of the drinking straws, is it smooth? Yeah, it's pretty smooth, right? But what would happen if you ran your hand across the top of those drinking straws? What will they do? they'll kind of spread apart, right? Well, that's exactly what the wood does. If you go and cut across the grain, when you get towards the end of the board, right about here, the board will split, and that big chunk of wood is going to go flying all the way to the back of the wall. All right, so not only is it dangerous, but it's going to ruin the piece you're working on anyway. So we always joint the edges, the grain going with the same direction you're moving the board. Does that make sense? Mm-hmm. Okay. Now let's talk a little bit about hand placement. All right, it's very important that our hands stay clear of that cutter head, right? So if our left hand is like this, you have your thumb on top of the board, okay? That kind of helps keep your hand from slipping. Also, your fingers are pushing the board down against the bed, up against the fence, okay? Your other hand should be back here, again, on top of the board, all right? Now, if we have a board that is not quite as big as this one, it's a little bit shorter, like this, or a little narrower, I should say. All right, same thing, you're gonna have your thumb and fingers like this. Your right hand should wrap around the back of the fence. Anyone want to take a guess why?
Because if it's on the wood, then you could have like a pinch spot.
You could have a what spot?
You know, where it pinches your hand.
Okay, oh, pinch point, like
Yeah.
from yesterday. Maybe, possibly.
To have control of the board.
Okay, this is the best way to control the board. Some of you were taught to hold it like this. The problem with that is if you slip, okay, see how you can lose control that way? All right, if you have your thumb and fingers like this and your other hand's wrapping around the back of the fence, there's no possible way you could slip and go into that cutter head, right? Okay, now to actually joint the edge of a board, our start-stop switch is here. I'm going to hold the board up against the fence, down against the bed, and I'm going to walk with my board across the machine. I'm not going to stand in one place. All right, so here we go. Okay? So it may seem like nothing was really done, just like yesterday, but really we've taken about a 1/16 of an inch off, and we've made sure that this edge is perfectly 90 degrees to this surface. Okay? All right, now, as far as the hands go, I just showed you guys the correct way to hold your hands. I want to talk about some improper ways to place your hands where you could possibly, or you will actually get hurt. Okay? If you were to do this, where your finger is touching the bed of the jointer, what do you think will happen? If I'm using my finger all the way, touching the bed, I'm pushing the board through.
You cut your finger off.
Okay, if you're taking a 1/16 of an inch off the edge of the board, how much is going to come off that finger? 1/16 of an inch. Okay, the machine doesn't know any different. So is that a preventable accident?
Yes.
Okay. Gentleman that my dad went to school with, high school, he's now 60 years old. He did just that. His teacher never really talked about not placing your fingers on the bed of the jointer. And he was pushing the board along with his middle finger, ran his finger across the cutter head, and to this day, he's 60 years old, he puts a plastic cap over the end of his finger and puts a new bandage on every morning. Okay? So, totally preventable, all right, but that affected him for the rest of his life. Okay? Another thing I want to talk about is sometimes when you're running this, the board will get stuck on the outfeed bed. Okay? What do you guys think you should do if that board gets stuck on the outfeed bed? What's that?
Pull it up.
Okay, lift it straight up. Perfect. All right, you could go back, lift it straight up. Do you think it would be a bad idea to reach your finger down
No.
and lift up? Yeah, absolutely a bad idea, right? Another story I have, kid I went to college with. All right, this is somebody who was in school to be a shop teacher as well. Okay, he was more of a metal worker. He was in a woodworking class, just like this, and he had a board getting stuck on the jointer. So he reached his middle finger down and lifted the board up. All right, he did it once and he just got lucky. The second time, as that cutter was spinning, you guys can see it comes up in this direction. Okay, that blade on the upside caught his middle finger and just kind of nicked him. All right, now this dude was humongous. Big, tall guy, very strong. he turned completely pale white because he was in so much pain. All right, and he ended up getting it all bandaged up, and luckily it healed, but he does have a scar. Okay, is that accident preventable?
Yeah.
Totally, right? You don't put your hands near the cutter head. Now, worst case scenario, right? I talked about him getting caught by the upside of the cutter, right? Well, what if your hand touched the blade as it was going down? What do you think could happen? Okay, it could pull your whole hand down, right? And I got news for you, folks. People always talk about, well, a saw cutting your finger off, right? If you get tangled up with a cutter head on a jointer, you've got nothing left but hamburger meat, okay? And I don't say that to scare you, all right? But is that all preventable?
Yeah.
Yes. If you place your hands where they're supposed to be and you do this correctly, you will never, ever get hurt, okay? All right, so any questions before we get started with taking turns using the jointer? Okay, so as you guys come up, you're going to have your left hand, thumb on top, fingers down. Your other hand will be up top. Now, obviously, I can't wrap my fingers around the fence because this board is pretty wide. All right, and that's okay. We're going to run through nice and slow, and then you'll cycle back around and get back in line. Okay? Do you guys have any questions before we get started? Okay, you guys all did a great job. I can see, and this is totally normal, that many of you were very nervous, okay? And you hear these gruesome stories, and then it's your turn to use the machine all of a sudden. If you were a little nervous, that's actually a good thing. If you're the type that said to yourself, this thing can't hurt me, you're the one who I have to worry about, okay? So if you're nervous, that's a good thing. You will gain a comfort level, okay? You'll be more comfortable as you use the machine. That doesn't mean you shouldn't be afraid of it, but you'll get used to using it, okay? Now, one thing I didn't talk about, we've got pretty big boards we were using today. What if I had to clean the edge up on this maybe 2-inch wide piece of wood? Do you think it would be very safe for me to do it the same way?
No.
No. All right, so anything 2 inches wide and less, we would grab a pair of these. Anybody know what these are called? Push sticks, very good. So what we're going to do is we're going to have one push stick up against the fence, the other push stick down against the bed, just like we were using our hands, and it's the same process. Okay? Much safer than just putting our hands that close to a cutter head, right?
Mm-hmm.
Okay. So let's do a quick review, and then we'll get our safety test out. All right. We have two tables here. These are called what? Anybody remember? Okay, beds. The in-feed bed and the out-feed bed. What do we call this thing that looks like a pork chop?
Pork chop.
The guard. Yeah, pork chop guard. All right. This thing right here is called what?
The fence.
Fence. And then what's the minimum length?
12 inches.
12 inches. Very good. Should our hands ever touch the bed?
No.
While the jointer's running? No. Is there ever a reason we would want to reach down and lift the board away from the cutter head?
No.
No, not close. If you grab your board and lift up, that's okay. All right. Do you stand in place or do you walk with your board as you go across?
Walk with your
Okay,
board.
you walk with it. All right. Let's see. Should your fingers ever hug the back of the fence?
Yes.
Yes, if possible, right? One thing we didn't really touch on, we did yesterday. What happens if you are distracted and something's going on? Should you look up?
No.
No, you always keep your eye on what you're doing, right? Is there ever a reason we need to touch the guard while the machine's running? No, it does its own thing, right? Let's see. Is there ever a time we would want to joint end green?
No.
No. Okay, very good. All right, guys, and what do we need to wear?
Safety vest.
You got it. Questions? All right, guys, thank you for your attention. Let's go do our safety test. So, some of you have used the radial arm saw before, as you said. What do we use the radial arm saw for? Does anyone know?
Cutting.
Yeah, cutting, but what kind of cutting? Anyone know?
Cutting wood in half.
Okay, what's that? You could use it for cutting dados. All right. Do we go across the grain or with the grain when we cut on a radial arm? Across. Very good. Going across the grain is called a cross cut. All right. If we were to cut with the grain, that's called a rip cut. So imagine a piece of paper. If you were ripping a piece of paper, that's a rip cut. So we don't do rip cutting on the radial arm saw. All right. I'm going to show you this machine was designed to be able to do both, but it's pretty dangerous to do rip cutting on a radial arm, so we'll use the table saw for that type of cut. Okay. The radial arm saw, just to give you guys a little bit of a background, was invented by a woodshop teacher actually in Lancaster County, Pennsylvania, a guy named Raymond DeWalt. All right, does anybody recognize that name? Okay, it's the yellow DeWalt tools that we have today. But he was just a teacher, and he invented this machine. This machine became really popular right after World War II when the housing boom hit. All the troops were coming back home, and they started building all these houses, right? And Ray DeWalt had designed his radial arm saws to, some of them be hooked up to car trailers. So instead of having legs, they would have trailer wheels and a license plate, and you would hook the radial arm saw up to your hitch and tow it to the job site, and you could make your cuts there, okay? Later on, it got picked up by Craftsman, and this particular model here became very popular with homeowners. All right, they were designed to do just about anything. All right, not only rip cutting and cross cutting, but they could do sanding. If you took the blade off, you could install a sanding disc and make it into a sander. There was a little planer attachment where it had like 3 little teeth that would spin around, and you could use it as a planer. If you guys look, both saws have these little red plastic pieces on the end that you could unscrew and put a drill chuck on, and then turn the motor sideways and raise it up and down, and now it's a drill press. So there was a lot of different gadgets that were sold with these. But we're only going to use it for cross-cutting because we have machinery that's designed to do all those other operations much better. Okay? Just some parts of the radial arm saw. We have, first of all, it's called radial, not radio or radio alarm saw. Okay? This doesn't play music and it doesn't alarm anything. Okay? So radial gets its name from the word ray. So if any of you have taken geometry class, you know a ray is a point with a line going in one direction. So we have a point back here, and the saw moves out in one direction. Okay, so that's how it gets its radial name. And then we have this big cast iron arm right up here. So this is the radial arm. Okay, what I just moved was called the carriage. Okay, the carriage has a handle that you would hold on to right here. We have a guard up top. And down below, this thing that moves up and down is called a leaf guard. I don't know why it's called a leaf guard, but that's what it's called, okay? Our start-stop switch is right up here, okay? And this thing can be set to make all different types of angles. We can angle the arm to 45 degrees or any of those angles by turning this. We can tilt the motor so that the blade cuts at a different angle, or we could do both. We could do what's called a compound angle. All right, but again, most of the time we're doing straight 90-degree cross cuts. All right, you guys see these red lines on the fence, right? All right, that's our safety zone. We have a 5-finger safety margin in here, 5-inch, I should say. So the rule is you have 5 fingers, you keep your hand 5 inches away from the blade. Does that make sense? All right, you're going to hear that as a theme a lot throughout these machines. Okay, just like yesterday when we talked about the jointer, we have a table and we have a fence. The board is always going to be held down against the table, up against the fence. All right? We want to make sure our hand is on top of the board, not grabbing the back of the fence. You should actually hold your piece. Okay? and we want to stay outside the red zone. All right. Now, as far as the correct way to hold the carriage, where to stand, all right, you want to use your right hand to hold onto the carriage. Your shoulder should be in line with the arm, and your left hand is going to be used to hold the board in place, okay? So we're going to have it just like this. When you start the saw, you should be holding onto that carriage, all right? So we're going to use our left hand to start the saw. Now, this control right here raises and lowers the saw blade, all right? So what do you think might happen if somebody messed with this and lowered the blade so it's touching the table and we started the saw? What? Okay, it could cut the table. What do you think might also happen? The blade's spinning in this direction. What's that? Okay, the carriage could walk out by itself. All right, just like a tire on a racetrack, as soon as it starts turning, it's going to go. So it might be a good idea when you come over here to kind of pull it out, see if the blade is touching the table, all right, before you start the saw. And that's the other reason you always want to hold the carriage while you're starting the saw, okay? All right, now, this board here has a nice jointed edge, right? Went through the jointer. But on the radial arm saw, a nice feature is you don't have to have a jointed edge. So if we had this rough sawn board from the sawmill, okay, and we wanted to cut it, that would be safe to do. When we learn about the miter saw, I'm going to show you why it's unsafe to do this on the miter saw, okay, and we'll learn the difference. Another thing, this board here has a slight bow to it. You guys see that, how it's rocking? All right. If a board's bowed like that, or if it's curved this way, it's cupped, okay, and it rocks around, do you think it would be safer to cut it this way, or if we flipped it up like that? Okay, so the high spot, that's called a crown. All right, the crown of the board should always face up. If we put the crown down, you guys see how it's moving, right? So that's not safe. So you should always have the crown of the board facing up, if it's bowed or cupped or anything like that, all right? Okay. Now, one thing you would not want to do is, we talked about hand placement. Do you think it would be a problem if my arms were crossed like this? Yes. Okay, it's kind of uncomfortable, impractical to do this anyway, but you never ever want to cross your arms. What could happen? Or what will happen? Yeah, you could potentially cut your arm off. All right? Easy way to prevent that, don't cross your arms. Keep your arms out of the way of where that saw is going to be, right? Okay. We do have a blast gate right up here. So we want to make sure our blast gate's open, or else the sawdust is going to kind of shoot right back in your face. So make sure it's open. We're going to have the dust collector running. All right? Okay. When we pull the saw carriage through, do you think we should go fast, slow, medium? What do you think we should do? You should probably go slow until you get a feel for what you're doing. All right? You guys are going to find that when we cut pine, it's nice and soft. It cuts a lot easier than something harder like oak or maple, and something thicker. So when we get to a thicker piece, do you think we should go faster or slower? Definitely slower, okay? The other thing you have to be aware of is, because the blade is spinning in this direction, the saw naturally wants to come out. So as you're holding on to that carriage, you almost want to be pushing backwards, all right? And you'll feel that as you come up. You're going to pull through, and then you'll return it to the back of the carriage, okay? Questions so far? All right, we're going to do a test cut. If you could turn on the dust collector, all right, and then we'll get you guys started here. All right, again, I'm holding my board down on the table, up against the fence. I'm going to go nice and slow. Okay, turn it off. Okay, right now I just made a random cut. Usually you're not going to be doing that. Usually you're going to want to cut something to a certain size, right? So let's say I've got this piece right here. By the way, you guys notice that blade's still spinning? Okay, it's going to spin a while. So somebody may have just made a cut, and you might come up to this machine. Be aware that the blade's still spinning, okay? Does that mean the motor's on, though? No. So always turn it on Okay, don't just pull it through, because what's going to happen? The blade will stop, like right in the middle of the cut. So always make sure you turn the saw on. All right, let's say I want to cut this piece. Right now it's 20 and a half. I want to make it 19 inches. Okay, so I'm going to mark a line. Do you guys think it would be best to mark the line in the middle of the board, the front of the board, or the back of the board?
The back.
Yeah, the back. Why?
You can line up the blade with the cut.
Exactly. All right, if the line is at the back of the board, you can easily line the blade up exactly where you want it. Now, this is my mark to 19 inches. Do I want to cut on the left side of the mark or the right side of the mark? The right side. That's very important. So I'm going to put a little X at the right side of the line so that that 1/8 inch wide blade is going to go to the side I don't need. All right? If I cut it on the other side, is it going to be perfectly 19 inches? No. All right? It's going to be 18 and 7/8. All right? So here we go. Now, if I'm standing straight up, I can't see that blade. I'm actually going to bend my head down while I'm holding the board and line up that line and make my cut. All right? Can we get the dust collector one more time? Here we go. Okay, sorry. You turn it off. Okay, you guys can, I'm going to pass this around, but if you take a look, my pencil line is still there, but it's sort of cut. All right, so I'm going to send that around. Let's say I didn't cut it quite to the right size. Let's say I went a little bit too big. Okay, what should I do? It's like maybe a 1/16 or a 32nd of an inch too long. Okay, I was hoping somebody would say sand it. If you take that board to the sander, will it still be a perfect 90-degree angle? No, it will not. Okay? So what you can do is come back to the radial arm. It's okay to use even the very edge of the saw blade to take just a tiny, tiny bit off. Okay, that's all right to do. So the best thing to do is always come back and trim just a little bit more until you're exactly where you want to be. All right, and then it'll stay nice and 90 degrees, nice and square. Okay? All right, couple quick stories before we get started with this. The first story I hope I never ever have to deal with, because this was just totally crazy. About 4 years ago at Steinert High School, there was a student who wondered what it would be like to cut his finger. So he went over to the radial arm saw, placed his hand, or his one finger down about an 1/8 inch towards the blade, pulled the saw right across. Okay, and obviously he cut his finger. He was taken out of the class and sent out for a psychiatric evaluation. All right, and that's not a joke. I mean, just clearly there was something wrong with this kid. So hopefully that's never going to be an issue. Is that preventable? Yeah. If you don't put your hand there, you're not going to cut yourself. Okay. Another story is from a place called Suburban Fence in Trenton. Some of you may be familiar with them. All right, it's a company that does fencing for commercial businesses and homes. All right, so they were doing a wooden fence. There was somebody at the radial arm saw cutting several pieces. Just slide the board down, cut it, slide another piece down, cut it, and I guess kind of lost his concentration a little bit, and he slid the board down with his arm like this and pulled the saw right across. Okay, you got to keep in mind, generally you guys won't be doing many cuts in a row like that. But if you do get in a situation where you have to do several cuts in a row, slow yourself down. Keep concentrating. All right, so that doesn't happen. Okay? Generally speaking, if you keep your hand out of the safety zone, which is marked on the fence and on the table, you will never ever get cut. All right? Now, I talked about rip cutting. This machine can actually be set to rip cut. It was designed to do that. If we raise the saw up a little bit, I can loosen the carriage and turn the saw sideways. We can lock it. And then this could be set so that we push boards along like a table saw and rip cut. That's extremely dangerous, even though it's designed to do this, because the blade is spinning up away from the table and it wants to lift the board up in the air. All right, so that's why we have our table saws for rip cutting. Okay? Now, if we go back to our cross-cutting position, lock this up. Okay. Do you guys think it would be a problem if we tried to rip cut this way? Absolutely. Okay, first of all, your hand's in the safety zone, right? But even if it wasn't, even if this was bigger, okay, I will be able to hear the difference. If somebody tries doing this, I can actually hear the saw is cutting the grain a different way. There's a different sound to it. But this was done where I student taught. There was a student that, before I got there, they had this exact same saw, and they tried to do this, and what happened was somehow the board broke apart and actually split the back part of the table in half. I don't know how it happened, but they saved the actual piece of table for me to see and for everyone to see. It was just incredible to see how powerful it was that that board was able to cut the table in half. Just amazing. All right, so we never ever do a rip cut with the grain here. We always go across the grain. Okay. Questions so far? Okay. If that blade is spinning, right? I mentioned how it spins for a while after you turn it off, and you come over here and you need to stop that blade. Is it a good idea to put a board in there and try and stop it? No. All right, just let it stop. Okay. All right. Questions? All right, what we're going to do is we're going to line up, and you're each going to take between a 1/2 inch and 1 inch, somewhere in there. I'll help you figure that out, off of the piece. You'll notice these little blocks that were laying next to the blade. Did I reach my hand in and take that away? No. All right, I just kind of carefully with the board pushed it out of the way. All right. So every time you guys come up, your right hand holds the carriage, left hand will turn the saw on. We're not worrying about lining up marks just yet for today. You'll make your cut, and then you'll get back in line. Okay? All right, guys, first of all, everyone did a great job. You'll notice it was pretty easy to cut that material. If you start getting into the harder pieces of wood that are thicker, you're going to notice a big difference. So that's when you have to really slow down, okay? One thing I wanted to share with you. Last year, when I was in my level 2 class, actually, the radial arm saw was turned on. I look up. And all of a sudden, as the kid is making his cut, I see tons and tons of sparks flying everywhere. So my first thought was, okay, something in the motor has gone wrong. Okay, and then my second thought was there's a nail or something is in that board that's making it spark. Okay, which is strange because this is all brand new lumber, right? So I yelled for him to turn the saw off, and when I came over, what I found was underneath what he was cutting was a ruler, okay? And you can see this ruler is kind of aged a little bit. It's kind of dark, and so is the table. So it's, I guess, easy to maybe not see if you're carrying a big piece of plywood that it's there. So he proceeded to cut almost all the way through the ruler, and in doing so, the saw blade that was on there, okay, this one right here, 6 of the teeth broke or were damaged. All right, and 6 of those teeth came off, and luckily those teeth went up the dust collector, because if those little sharp teeth come out flying at you, it might hurt a little bit or it might cut you. So luckily nobody was hurt, but in the matter of about 2 seconds, a $50 ruler was destroyed and a $100 saw blade was destroyed. All right, so $150 in about 2 seconds, gone. All right, so the moral of the story is do not get in the habit of leaving tools on a machine top. All right, we want to try and keep rulers and stuff like this on the workbenches. All right, but I saved this. This will be up front for you guys to check it out after your test today. But it's pretty impressive there. Okay. All right, let's go over the lesson here. Make sure we covered everything. All right, just for a little review. Anybody remember what this is? Okay, the top part's just the saw guard, and the bottom would be the leaf guard. Very good. Okay. This part right here that's made of cast iron is what? The arm. Okay. And then the part that slides back and forth? The carriage. Very good. All right. Can we set this up to make rip cuts? Yes, we can. Would we ever want to do it here at school? No, because we have table saws. We don't need to do it. It's dangerous. Right. Is there ever a time where it's safe to rip cut in the cross cut position like this? No, that's something you never ever do. Okay. What is the safety margin? 5 inches. Yes. So you got to keep your hand 5 inches away from the blade on either side. Okay. Would we pull the carriage at a fast speed or a slower speed? Yeah, you want to go slower. Okay. What do we do with a bowed or cupped piece of wood? Does the crown go up or does the crown go down? Crown always goes up. Very good. Let's see. If the blade's still spinning after you turn the machine off, should you try and stop it with a piece of wood? No. Okay. And then what do we want to do before we start the saw for the first time? Well, yeah, hold the carriage. Who said it? Who said it? Yeah, very good. Make sure that the blade is not touching the table. All right, and the way you do that, just kind of move the carriage a little bit. If the blade doesn't move with the table, then you're good. Okay? Any questions? All right, guys, great job. We can put our safety glasses back and we'll get our test started. All right, a miter saw gets its name because it's designed to be good at doing miter cuts, all right, which is cutting on a 45-degree angle. All right, so right now the saw is set for 90-degree cut, which we'll be doing today. But I'm going to show you guys the different types of angles and cuts that it can make. Of course, we'll talk about the safety stuff, and then we'll get you guys practicing with it. And of course, we'll do our safety test. All right, so when you guys come in, beginning of the period, you're going to find the saw locked in the down position, just like this. All right, the way you unlock it, and I guarantee you some of you are going to come and see me because you'll forget how to do this. But underneath the motor, right here, there's a silver pin. You push down on the handle, pull the pin out, and the saw will come right up. Okay? We've got a D handle. Anybody know why they call that a D handle?
Looks like a D.
Yeah, it looks like a capital D. Okay, and we have a trigger switch, all right, to turn the saw on and off. You have to use the D handle and the trigger switch at the same time, right? It's pretty hard to not use them at the same time, all right? We have a big table, and we also have one of these things. What do we call this? A fence, okay? Starting to see a theme here. Table and a fence. This piece that covers the blade would be the guard, very good. And if we wanted to check the guard to see if it was working properly, we could just move the saw up and down. All right, if it moves out of the way and back and covers the blade, then it's working correctly. Okay? Now, the way we change angles. Right here, this little handle is a lock. All right, to unlock it, we lift up. And if I try to move the saw, it still will not move. All right, the reason is we have what's called a positive stop. All right, the positive stop button is right here. So if we press that down, we can then move the saw to the different angles. Okay? The reason we have a positive stop is along here we have different cutouts, little notches, at very common angles. 90 degrees, 45 degrees, 30 degrees, 22.5 degrees. Anybody know why 22.5? That seems like a random number.
Half of 45.
Very good. Half of 45 degrees. All right, sometimes you need that if your two pieces have to come together to make a 45-degree angle. They need to be cut at 22.5. So there's a red arrow that hopefully you guys can see. that will point to whatever angle that you're trying to get. All right, and the positive stop will lock in, okay, at the angle. Now, is it safe to start cutting right now?
No.
Why not?
There's no wood on it.
Well, I didn't. You said there's no wood. Yeah, I'm not going to cut anything, but this was not locked. Okay, you got to make sure you lock the miter saw before you go and make your cuts. All right, don't just rely on the positive stop. All right, so just push this handle down. Okay. Now we have a safety margin at the miter saw. What do you guys think it is?
Where's
5
safety
inches.
glass?
Safety
5
margin, not safety glasses.
5 inches?
Yes, you have 5 fingers. You keep your hands 5 inches away, right? Okay. Now, on the saw, there's a line with a little symbol for where you shouldn't have your hand. That line is more than 5 inches away, okay? That's just what the saw manufacturer decided would be a good number, okay? I'm telling you, if your hand is 5 inches away or more, you're going to be fine, okay? All right, so let's say I want to cut this piece, all right? I want to make a cut, and we're going to see how long this piece is here. This one is 27.5 inches. And let's say I want to make it 26 inches, okay? Now, when we were at the radial arm saw, did I mark the front, the back, or the middle of the board? Okay, I marked the back. All right, so if I'm at 26 inches, I'm going to mark the back, put my X. And if I set it up to the miter saw, what's my problem with putting the mark in the back?
If it's in the back, like the saw doesn't touch the back at first. So.
Exactly. Okay, what he said was the saw blade doesn't touch the back of the board first. It touches the front of the board. So if that's the case, where do you guys think we should put our line? At the front. So it's different than the radial arm saw. Now, if this board was really wide, where would we put the mark? Right in the middle. Very good. Okay, so I'm going to switch that around, remark it at 26 inches. Put my X there. And I'm going to get set up to cut. I'm going to hold my hand so I'm on top of the board, just like with the radial arm. Okay? Hold it down on the table, up against the fence, nice and tight. I'm going to bring the D handle down, and I'm going to line it up. Okay? Do you think it would be better to cut the board a little too big or a little too small?
A little too big.
Definitely a little too big. So I'm going to overcut it a little bit, and I can always go back and make it smaller. All right? Do you think I should ever start the saw while it's touching the wood?
No.
No, you always want to start it in the air. We're going to make our cut, and then once the cut's finished, I'm going to turn the saw off, let it totally stop. I'm going to wait till the blade stops, and then I'll lift it back up. All right? If we lift it up while the saw is still spinning, the little block of wood could get kicked up in the air. All right? Okay, so I'm going to keep my hand at least 5 inches away. I'm going to start it, and we're going to make our cut. I'm going to line it up. Okay.
Mr. Friedman?
Yes, sir.
Is this machine attached to the sawdust collector?
Yes, it is. We're going to run that. Very good question. Okay, so you guys can see I made my cut a little bit oversized than what it should be, but I can go back and clean that up. Okay? All right, so we've been saying about down against the table, up against the fence. What do you think would happen if I held the board out here away from the fence and made my cut? Any? Yes. Okay, he said it'll shoot the board towards the fence. The blade's spinning in this direction, so as soon as it hits, all right, it's going to slam it against the fence, probably with 10 times that intensity and scariness, and the board may blow apart into many pieces. Okay, so it's very important we always keep it against the fence. All right. Do you ever think it would be a good idea, Nor, to cross your arms while you're using the saw? No, just like on the radial arm, you never ever cross your arms. You guys can see how that could be a problem, right? Okay. Now, would it be okay if I switched hands and used the saw this way?
Yeah.
Absolutely. Okay, as long as you don't cross your arms, you can work on either side. Does that make sense? Okay. I want to show you guys some angled cuts. So we're going to go to very common angle, 45 degrees for a miter cut. It's the same thing. We're going to hold the board in place, make our cut, and then we'll see what we can do with that. All right, here we go. Okay. So with a 45-degree cut like this, when we bring the boards together, have you guys seen a joint like that before?
Yeah.
Where might you see something like that?
Door.
Okay,
Picture
door frame, picture frame. Where else?
Door.
Possibly a table.
Door.
Okay, a door. Possibly some trim around a window, something like that. Okay, very, very handy joint to know how to make. Now, you guys will be doing miter joints a lot this year when you build your tiny furniture. Okay. The tricky thing is your molding for the tiny piece of furniture is going to be a very thin strip of wood. So, first of all, do you think it would be better to go faster or slower for that thin piece? Very, very slow. Because what happens is, this board is pretty rigid, right? Because it's big. When you get a thin strip of wood, it starts to get a little more flexible. So what happens is you need to hold it a little bit close and really, really tight. Because as soon as that blade hits that little piece of wood, it wants to lift it off the table. All right, we'll talk about that a little more as you guys get closer to that stage. But while we're on the subject, do you think it's safer to hold our hand 5 inches away or to keep our hand at the very end of the board really far away? Definitely 5 inches. Because check it out. If I hold it at the end and I think I'm being safe this way, the blade can easily lift this off the table. All right, if my hand is close, there's no way that can come off the table. All right, does that make sense? Okay. This is called a compound miter saw. All right, and what that means is not only can it angle left and right, but we can tilt the blade different angles. So we're going to do that. We're going to do a compound cut. I'm going to bring this back to, like, I don't know, different angle. Just try it. We're going to unlock this, tilt the saw a little bit that way. All right, and this is completely random. I just want to show you guys the different types of cuts. Okay, and it's the same process. We're holding it down against the table, up on the fence, and we're going to make this cut. Okay, so now we can get to doing crazy stuff like this. All right, you guys probably won't have to do compound angles much, but you might, depending on what you build this year. All right, so it's good to know that this saw can do stuff like that. All right, now, typically my students, for whatever reason, are terrified of the miter saw. And really, there's no reason to be. I think it just sounds super scary because it sounds really gnarly. You know, this saw here was made in China. It's made of plastic and aluminum parts. All right, so it's not a well-built machine compared to like the radial arm saw where it's all cast iron. Okay, so this sounds a lot worse than it really is. Basically, if your hands are where they're supposed to be and you're doing everything correctly, it's not going to hurt you. Okay, yes sir.
Does this have the laser line?
No. What he's talking about is some saws now have a little laser that'll put a line down so you don't have to line up the blade every time, but we're not fancy like that. So we don't have that. Okay. Questions so far about the miter saw? All right. The other reason I think my students were terrified of this machine is because it's a sliding miter saw, meaning not only does it go up and down, but the saw blade can slide out. I've disabled that sliding feature because what would happen is from the saw moving in all different directions, we would get kickbacks. All right, the blade would get pinched and the saw would raise up very quickly and kind of in a scary way. All right, the reason a kickback happens usually on a miter saw is if you don't have a nice jointed edge, right? Remember we talked about this machine, you have to have a jointed edge, whereas the radial arm saw, you don't necessarily need a jointed edge. Here's the reason for that. All right, if we have a board like this, the edge is not jointed, right? And we hold it up on the fence, and there's some gaps between the board and the fence, right? We said on the radial arm saw, it cuts from where to where? Back to front. The miter saw cuts from where to where? Front to back. So imagine there's a gap in the back here by the fence. We're pushing against the fence, the saw starts to cut the front of the board. So while we're pushing against the fence, that little gap that the saw blade makes, called the saw kerf, does that get bigger or smaller? Gets smaller. Okay, so now that wood starts squeezing the blade, and the blade doesn't like to be squeezed. So as soon as the blade gets pinched like that, the board will kick back, the saw will come flying up. Quite scary. The radial arm saw, however, we're cutting from the back to the front. As you're holding on, does that saw kerf get bigger or smaller? Bigger. So that's the difference. All right, it's just a design feature. So when we're cutting on the miter saw, we have to have what type of edge? Jointed edge. Very good. Okay. All right. So we're going to set this back to 90 degrees. We're going to have you guys take some turns making cuts.
I didn't see how you turned it on.
Okay, the trigger switch, right on the D handle. Good question. All right. Are we good to go?
Yes.
Why not?
It's not locked in.
All right, I forgot to lock it. Very good. So make sure it's always locked. Okay. Any questions before we get started? All right, some of you that have like anything dangling, anything loose, needs to either take it off or tuck it in or whatever, okay? I would take that off, absolutely. All right, so if we could, we're going to start the dust collector, form a line, and we'll all take turns. We're going to cut about 3/4 of an inch off of each piece. All right, guys? Ready? Again, great job, just like you've been doing as far as your first cut and everything. My only suggestion for some of you, just make sure that blade stops completely before you raise the saw back up, okay? All right, do you think it would be a good idea if we had a board that had a twist in it to cut it? No. All right, there's other ways to get around working with a piece like that. Sometimes with the radial arm saw, we may be able to get away with cutting a piece like that. The miter saw, different story, okay? All right, so let's just do a little bit of a review, okay? If we wanted to check the guard to make sure it's working properly, how would we do that?
You just turn it down, but you don't turn it on.
Okay, just move it up and down. If the guard moves away and covers the blade, then we're good to go. Is it a good idea to talk with your friends while you're working on the miter saw? No. All right. What are the two parts that you use at the same time called?
D-handle and trigger.
D-handle and trigger switch. Very good. Do we make any adjustments while the saw is running?
No.
No. It'd be kind of hard to do that anyway, right?
Yeah.
All right. What would happen if the board was not held against the fence?
Shoot towards the fence.
Right. So you got to make sure we always hold it against the fence, down on the table. Is it ever a good idea to start the saw while it's touching the piece of wood?
No.
No. All right. Why do we never cross our arms or hands?
Saw it off.
Yes, you don't want to cut yourself. Very good. What's the safety margin?
5 inches.
5 inches. Very good. And what do we have to wear?
Safety goggles.
Excellent. All right, guys, you can take a seat and we'll get our tests out.
I wasn't here yesterday.
This is our bandsaw, one of our bandsaws, okay? First of all, the name of the saw, band saw, it's not B-A-N, as a lot of people think. It's B-A-N-D, like rubber band, all right? And the way it gets that name is if we were to open this wheel guard here, all right? We basically have a top wheel and a lower wheel, okay? You want to hold that open? Be careful, it's a little sharp. Top wheel, lower wheel, and this continuous band of a blade, Okay, so that's how it gets its name, bandsaw. The lower wheel is what's connected to the electric motor, so the lower wheel spins. As the lower wheel spins, because the blade connects the top wheel spins as well. Okay? The blade moves down towards the table. Does anyone know why? Like, why wouldn't it go the other way, away from the table? Okay, yeah, it's going to want to lift the board off the table. So by going down towards the table, it helps keep the board flat on the machine top. Okay? Alright, so I wanted to open that so you guys can see what's going on inside. Do you think there's ever a reason you guys would need to open the wheel guards? No, they should stay closed and locked at all times. Alright? So we're going to lock that back up. Thank you, sir. We're going to close the bottom door. Lock that back up. Alright, some of the other parts to the bandsaw. We have this blade guide and guard. Alright, it's a combination. Up here we have a blade guard, which protects your hands from the blade. But you got to be aware that behind the blade guard, it is open. Alright, so if for some reason you were to reach your hand back here, which you shouldn't do, that blade's totally exposed. Okay? We also call this a blade guide. I'm going to turn this little light on. You guys can see that there are wheel bearings. Okay, so there's a little bearing on both sides of the blade, and there's a bearing behind the blade. And what they do is support the blade as it's cutting. So when we're pushing back on the blade, okay, it's going to rest on that back bearing, and it's going to roll and support the blade. As we try to turn our piece of wood, the blade wants to turn with it. So these wheels are going to hold it and keep it from spinning or turning. All right. There is no bearing on the front of the blade, though. So what do you think might happen if we pull back too fast? We could break the blade. What else could we do?
Cut your finger.
Yeah. What else? What's that? No. All right, well, if you pull backwards too quickly, and it's okay to back out of a cut, by the way, but if you have to back out, you always back out slowly. If you pull back too quickly, we could pull this blade right off the wheels, because there's nothing holding the blade from, like these bearings support the blade in the back and the sides, okay? Now, to adjust the height of this guide and guard, we loosen this knob right on the side here. It looks just like this, but it's on the side. And we can raise or lower to the correct height, all right? What do you guys think is a good height to cut with? 1 or 2 inches above? Can your finger fit under 1 or 2 inches? Yeah, so my rule of thumb is a 1/4 inch. All right, do you have to get a ruler out and measure a 1/4 inch? No. I like to use the tip of my pointer finger under this part right here, lower it down until it touches the board, and that's about the correct setting, okay? So again, as long as it's just a little bit above, you lock the adjustment wheel, then you're good to go, okay? So that's our blade guide. Now, if I set it all the way like this, will it still cut?
Yes.
Yes, it will, okay? Is it safe to cut that way?
No.
No, there's no need to have all this blade exposed. So if that's the case, why does the machine guard go that high anyway?
Big boards.
Okay, bigger boards. If you guys are doing guitar, specifically like a Les Paul, you'll see that later. We're going to do a process called resawing. All right, today we're just cutting the board flat, but sometimes with resawing, we'll take a fancy piece of wood that has a really nice grain pattern, and we'll stand it up on edge, and we'll cut it right down the middle, and then open the board up like a book. All right, and then when we glue those together, you're going to have a line right down the center, and the grain is going to be a mirror image on both sides. If you've ever looked at a guitar, you might have noticed that. All right, that's called book matching. So this machine can do book matching. All right, but you probably won't do that unless you're working on a guitar. Landon, please keep your glasses on. Thank you. Okay, so what we're going to do is, by the way, what kind of cuts can we do on a bandsaw?
Curved cuts.
Okay, definitely curved cuts. Can we make a straight cut?
Yeah.
Yes, we can. Will it make a perfectly straight cut like a table saw or a radial arm saw would make?
No.
No. Okay, so if your goal is a perfect straight cut, this is not the machine for you. All right? Curved cuts are what these machines are best at. Okay? So while we're actually using the machine today and cutting stuff, I figured we might as well make something useful. So we're going to cut out another one of these push sticks, okay? The one you guys saw the other day was a little smaller. These longer ones are for the big table saw. All right, so what I'm going to do is line up my pattern. I'm just going to trace it on. Okay. Now, do you guys think that when I go to cut this piece, should I be on the line, inside the line, or outside the line? Outside the line. Very good. The reason is if I cut my line away, now I don't know what shape it's supposed to be. All right. When you're all done on the bandsaw, your line should still be there, so then you can take it to a sander and sand it perfectly to the shape you want it. All right. So that's really important. What do you think you should do if you feel like you're going to cut into your line?
Pull out.
Okay, pull it backwards. Maybe you are stuck though. You can't pull backwards. You feel like the only way you can go is forwards. Then what? Okay, turn the machine off. Come and get me. I will help you. All right, absolute worst case scenario. You have no other choice. You have to cut your line. Then you have to cut your line. And you may have to start over. All right, but try to avoid that. Okay? All right, now, as far as safety goes, we already talked about the height of the guard / guide. So we're going to reset this to the correct height and tighten that up. All right. The other thing you guys need to be aware of is the invisible cut line. All that is an imaginary line from the front of the blade to the edge of the table. Okay. Basically, if you keep your hand out of that invisible cut line, you will never get cut on a bandsaw. Okay. But the most common cut on the bandsaw is right here, right on your thumb. All right, because what people tend to do, they feel comfortable holding the board like this, and then they slip and they cut their thumb. Okay, so if your hands are outside of that invisible cut line, you'll never get cut. Okay, now as far as where to stand, this where I'm at right now is the worst place you could possibly stand while the machine's running. Does anyone know why?
The blade will shoot out that way. If
Why?
It breaks.
Okay, he got it exactly right. I've never seen this happen, okay? But blades do break, all right? We'll probably break at least one this school year. Most of the time, 99% of the time, the blade will stay inside the machine and the blade will just stop moving, all right? But there have been times, it's recorded, accidents where the blade has broken and hit the table and then it flies out in this direction, okay? And now you've got essentially a metal whip with teeth on it flying through the air. So this is the worst spot you could stand, even if you're waiting to use the saw. All right, where you always stand should be right here, right in front of the machine. Okay. Now, the bandsaw is good at cutting curves, but sometimes we have a curve that's so sharp that the blade won't turn sharp enough. All right, this push stick will not be a problem. All right, but if I were to cut a curve out like that, okay, it's not going to make that turn. So what you're going to see me do, I'm going to demonstrate this. I'm going to make several straight cuts in, and I'm going to stop right before the line, and then I'm going to cut my curve. Those little straight cuts are called relief cuts. All right, and you're going to see how by doing that, it's going to make it a lot easier to turn because little pieces of wood are going to break away and give the blade room to move. All right, so I'm going to do my sharp turn first just to show you guys relief cutting. And then we're going to cut out the push stick. This 90-degree angle in here, do you think I'm going to be able to come in and turn 90 degrees?
No.
No. So I'm going to go straight in and stop. Then I'm going to come out, come straight in and stop there as well. Okay? All right. Questions before we get started? All right, here we go. I'm going to turn the dust collector on, please. We've got our blast gate right up here. Okay, turn off the dust collector, please. Okay, you guys see how we can still see our pencil line? All right, that's important. By the way, you just heard that like loud buzzing sound. This has an electrical brake on it. So through electricity and electromagnetism, it can slow the saw down instantly. All right, so it has that brake. Speaking of brake, if you're cutting along and all of a sudden, boom, blade breaks, it's going to make a loud bang. What should you do? Okay, turn the machine off, come and get me. Even if I'm across the room and there's a bunch of people working, I will probably still hear it, and I'll come over anyway. So if the blade breaks, you turn it off, you're waiting for me to come over, do you think it would be a good idea to open this up and see what's going on?
No.
No, because think about it. The motor's connected to which wheel?
The bottom.
The bottom. You turn the saw off, which wheel is going to stop?
The bottom.
The bottom. The only reason the top wheel stops is because the blade is connected to the top wheel. Well, now that the blade's broken, this upper wheel is going to do what?
You keep moving.
It's going to keep spinning for about 5 minutes. So I'll come over and I'll listen for that wheel to stop spinning. We'll unplug the saw and we'll put a new blade on. Okay? All right. So we talked about backing out of a cut nice and slow. All right. We talked about what to do if we get into a spot where we can't turn. Do you think it would be good to force the board around a tight turn? No. Okay. Another thing, as far as making curved cuts, all right? When we have to make a really sharp cut, what should we do before we make that curve? What will help us? What type of cut?
Relief cut.
Relief cuts, very good. Okay. All right, any questions on this bandsaw? All right, so let's take a little walk. We're gonna go over to the little bandsaw. I wanna show you guys a few things about that machine that's different, and then we're going to review for our test, and we'll do our test. All right, so let's go over to the other saw. Over at this smaller bandsaw, it's basically the same machine. It's just a little bit smaller. It has a few different features I'm going to go over. But the one other thing I wanted to talk about is your hand placement. All right, we know to keep our hands out of that invisible cut line. All right, but after we've been cutting a while, we get a lot of tiny blocks of wood, little scrap pieces laying next to the blade. Do you think it would be a good idea to reach your hand in and flick it away or wipe it away?
No.
No. All right, those little tiny pieces of scrap wood are not worth you injuring yourself potentially for the rest of your life, right? So what's the best way to get rid of that scrap wood?
Use the wood you're
All right, I heard turn it off. You could.
cutting and pushing out with a piece of wood.
Okay, if you have a scrap piece of wood or even your project, I probably wouldn't recommend it because you could mess your project up, but you could take a board that's long, okay, like this, and press it out of the way. What else? What if it's a bunch of small pieces? What else could you do?
Blow it away.
Yeah, just blow it away, okay? But never reach your hand in to get rid of that scrap wood, all right? Now, we talked about a few differences that this saw has. The other saw, when I loosened up the blade guard, it stayed in place. That's because it has a counterweight system on a pulley. This doesn't have that. So if the guard's way up and we loosen it, it's just gonna crash down. Maybe on your hand, maybe it'll just crash down and break the guard. So you always have to hold the guard, and back here there's a yellow screw that we loosen up, and then we can adjust it that way, okay? So that's one thing to be aware of. The other thing on this bandsaw, okay, this is a wood metal cutting bandsaw. So the cool thing about this machine is it's got a little transmission and a little shifter. And we can move that shifter into a lower gear and it'll slow this down a lot. And then you could put a metal cutting blade on it and we can cut metal with it. Those of you that end up taking level 2 will end up using this next door to cut metal. Right now it's set up for wood cutting and it's got a wood blade on it. So everything else is exactly the same. I just want you guys to be aware of the guard, okay? And the other thing I mentioned earlier is that the guard is open on this side. All right, a couple years ago, my brother had a kid over at Grice who did the right thing. They turned the machine off because they had to adjust the blade guard, but they didn't wait for the saw to stop. And they reached their hand just like this, right behind the blade guard. Luckily, the kid only got a tiny cut, which resulted in a Band-Aid, but Could that be much worse?
Yeah.
Yes. Do you think the bandsaw could amputate a finger? Absolutely. All right, just keep in mind, as long as you're out of that invisible cut line and you don't do something silly like reaching your hand behind the guard, you'll never get cut. Okay? Questions so far? All right, let's review, make sure we've covered everything, and then we'll get our test out. All right? Is there ever a time we want to open the wheel guards? No. Okay? Would it be a good idea to look away while you're making a cut? No. All right. Should the blade guard be within 4 inches of the piece being cut? No. 1/4 of an inch, right? Not 4 inches. Do we make any adjustments while the machine's running? No. All right. Is it ever okay to force a turn around a tight curve? No. All right. Good. We talked about never crossing the invisible cut line. When you're making relief cuts and you have to pull backwards, how should you do that?
Slow.
Yeah, nice and slow so you don't pull the blade off the wheels. Okay? What do you do when the blade breaks? Turn it off, come and get me. Okay? Is it safe to stand to the right of the bandsaw where I'm standing right now? No. All right, obviously it's not running, so that's okay now, but while it's running, we don't do that. All right, and you've got small scrap wood next to the blade moving. What should you do?
Blow it away.
Blow it away, use a push stick, whatever, but not reach your fingers in. Okay? Questions? All right, guys, great. Let's go do our test. This is our scroll saw. It's actually one of 3 that we have, right? So there's the 2 here, and I don't know, some of you may have noticed there's an identical one on the other side of that drill press. Okay, and really we only use that 3rd one during Toys for Tots. We'll set it up on a workbench, and it's just an extra workstation, okay? Some basic parts to the scroll saw, all right? Very much like a bandsaw in that we have an invisible cut line, right, from the front of the blade to the edge of the table, okay? We also have a blade guide and guard, just like on the bandsaw, all right? On this one, however, the blade guard is more of a finger guard. It's like a wire that if you were to somehow have your hand in front of the blade and slip, chances are you would hit the finger guard before you would hit the blade, hopefully. The adjustment is simply by loosening this handle and raising and lowering the blade guard, okay? Now, this saw goes up and down, all right? If you remember yesterday, the bandsaw goes which direction only? It only goes down. So this creates a new interesting problem, all right? Because the blade goes up and down, what could happen to the material as you're cutting it? Yeah, it can start chattering, all right, moving around. So this blade guide and guard has a little hold down, a little spring-loaded kind of a fork thing that presses down on the board. So for that reason, would we want the guard to be about 1/4 inch above or directly on top?
On top.
Directly on top. So what you do is you set whatever you're cutting right to the side of the blade, drop the guard down, and tighten up the setting, okay? All right, so this one I like just because we have this fancy little light. We can see what we're doing while we're working. On the top and bottom, we have a blade clamp, and all it is this little thumb screw. We loosen that up. I can reach down and loosen the bottom one, and we can remove the blade. All right, this is probably a medium-sized blade. I'm going to pass that around so you guys can check that out, okay? And like we said, we use the scroll saw for making those really detailed, intricate cuts, right? So that medium-sized blade is probably what you might use most of the time. We do have these larger blades, okay, which are meant for a little more heavy cutting, but do you guys think if we had like a big piece of plywood that we wanted to rip cut, would this be a good machine to use? No. All right, this is meant for those really detailed, small type of projects. I'm going to pass this blade around. Just be careful, it's sharp. So that's, a bigger blade, okay? And when you get into projects like the Beatles picture I passed around, or fretwork, which is something like this, I'm going to pass this around. This is just like a miniature model of a building with a clock tower. Very, very cool project. So if you're interested in doing something like that to start out, that's great. something like that in that picture would probably take all school year, but you could also do something a little more basic, a little bit more simple, that still has a lot of that fine detail, all right? For something like that or the Beatles, we would use this one here is called a 3/0 blade, all right? That's when we get into, instead of like 1/4 inch or 1/8 inch size blades, we start measuring them by almost fractions with a 0. So 1/0 would be 1/0, 2/0 is 2/0, and so on. The higher the number, so like 3/0 would be a smaller blade than a 1/0 blade. This one you can barely see the teeth. If you hold it up to the light, you can maybe see it, but you can definitely feel the teeth. So I'm going to pass around that 1/0 blade. All right, that would be good for doing those super detailed cuts like the Beatles picture, or even some of the fretwork on that picture I'm passing around now. Okay? All right, so when we install the scroll saw blade, okay? Let's see, we've got that one going around. I'm going to take another blade out here. Oh, you got it. Perfect. All right, we've got teeth pointing in one direction. Do you guys think the teeth should point up or down? Okay, down. Some of you might be saying, well, the blade moves up and down. What's the difference? Well, when it actually makes the cut, it cuts in the direction the teeth point. So when it's actually cutting, we want it to push down towards the table so it helps hold it down. All right? So what I'm going to do is raise my guard, move this little circle. This is called a throat plate. I'm going to move that out of the way. And I'm going to look to make sure the teeth point down towards the table. And we're going to clamp it into this blade clamp. Make it nice and tight. Set my throat plate back in. I'm going to adjust my guard all the way down. And if I were to open this door on the side, we could turn the belt and make the blade move up and down. On the other saw, there's just a hand wheel, okay, that we could spin. But the reason I'm showing you guys this is what you want to do is make sure the blade is all the way at the bottom of the travel. So once it's all the way down, we're going to pull our blade clamp from the top down and tighten it up. And you want to spin it one time around to make sure the blade isn't going to bind or bend or anything like that. You want to make sure it's working properly. All right, so this one, I'm just going to adjust a little bit. Test it again. Okay, so that's about where it should be. All right, I'm going to close my little guard up here, and we're ready to go. For today, I've got the whole alphabet here. I've been slowly working on cutting these out for patterns. So when we do like the letters on the wall, little sayings, this is a smaller letter template we can use. And if you guys wanted to do a sign, you could use these as well. So we're going to kind of kill two birds with one stone, get some of these cut out while we're also learning about this. All right. We talked about an invisible cut line, right? You may see as I'm turning this around, I might put my hand in the cut line, but I'll probably remember to move my hand away as soon as possible. All right, so generally you do want to keep your hands to the side as best as you can, okay? The other thing you're going to see is how quick I can make turns. All right, the bandsaw we had to make what? Relief cuts. We had to go slowly. We have a small blade in here that can turn almost a perfect 90-degree angle, just like that. Okay. Let's see. We're gonna try letter G. All right. So here we go. Okay, so just like yesterday, did I cut on the line, outside the line, or inside the line? Outside the line, okay? So this one I'll sand down to the line. When you get into those really detailed cuts like the Beatles pictures, you don't have room to go outside the line. So that's where you very carefully just cut right on the line, all right? So that would be a little bit different. Okay, so questions so far? All right, what happens if I'm in the middle of a cut and all of a sudden this starts chattering like this? What should I do?
Stop going too often to shoot.
I could. What else could I do? Why is that happening, first of all?
Because the blade's going up and down, and the wood can get stuck inside the blade.
Okay, so the blade is lifting the board up and slamming it down. So how could you prevent that?
Push it down.
Lay it down.
Just, yeah, push it down harder, so hold it tight. Especially when you get a thicker piece of wood, that might happen, all right? So it might be a little scary. Instead of just panicking, the best thing to do is just press down and it'll stop chattering like that, okay? All right, we talked about keeping our hands to the side, right? Can this blade cut you?
Yes.
Absolutely. If it cuts wood, it will cut your finger. Can it amputate a finger? If you really try, yeah, it could. But generally, because it moves up and down, it's not going to quickly amputate a finger. So most of the time, injuries on a scroll saw end up, result in just a Band-Aid. But that doesn't mean we shouldn't respect it any less, right? Because it still is capable of injuring you. So yes, it can cut your finger off. You'd really have to try to do that. So this is considered more of a safe machine than, let's say, the bandsaw, okay? All right, did everyone get the clock picture? You got to see that? Okay, thank you. All right, awesome. So if you're interested, hopefully some of you may be interested in doing your first project, something like this with the fretwork. If you're interested, we can look at different project plan ideas. You don't have to draw this up. This could be something that we print a project pattern, glue it down, and you just follow the lines, all right? So if you're interested in that, that's great. If not, some of you may never use the scroll saw because you just don't have an interest, all right? And that's fine too. Okay, let's say you're cutting a while on the scroll saw and it's not cutting as easily. What do you think the problem is? The blade, what? Yes, the blade does get dull. All right, these little tiny ones, especially that 3/0 one I passed around, the super tiny one, these break very easily. So before they get dull, they'll probably just break. Not a problem. I have thousands of blades. We can just give you a new blade. If you don't want to install it yourself, I can certainly help you. All right. These bigger blades, however, these will get dull, and they'll turn like a bluish purple color. All right, and that's called superheating. The metal gets so hot that it turns colors. When that happens, usually the blade is too dull. So instead of forcing it and just making it cut harder, just replace the blade. Come and ask me for a new blade. We'll take care of it. Okay? And again, which way do the teeth point?
Down.
Down. Very good. All right, so let's do a quick review, and we'll make sure we've covered everything, and then we'll get you your test. All right? Would we use the scroll saw mostly for cutting or rip cutting big pieces of wood?
No.
No. What type of cuts do we make?
Intricate.
Intricate, detailed, fine cuts. Very good. If the blade is not cutting easily, should you just push harder?
No.
No. All right. The blade guard and guide, should it be directly on top of the board or a little bit above? Very good. Directly on top. What do we have to wear while we're using the scroll saw? Good. Okay. Do you have to clamp both the top and bottom blade clamp? Yes. All right. If you leave one unlocked, let's say the bottom one is left tight and you don't tighten the top one, the blade's going to kind of flop around. All right. If you only tighten the top, the blade's not going to move at all. All right. Is there an invisible cut line?
Yes.
Yes, there is. Okay. Why does wood start bouncing around on the table?
Because the blade's trying to push up.
Okay. And what else? You're not holding it tight enough, right? Good, Lexi. All right. Is it safe to make an internal cut?
Yes.
Absolutely. Okay. And do we make adjustments with the power on or off? Very good. All right. Questions? Okay, guys. Let's go do our test. Great job. Alright, so this is one of our 2 drill presses. The one over by the little bandsaw is the exact same machine, so there's no really a need to go over there and talk about that one at all. Alright, just some parts to our drill press. Okay, we have this handle here called a quill. Alright, we have our chuck, and this is what holds on to the drill bit. So by turning this part of the chuck, you guys are going to start to see these jaws come down, and that will grab onto our drill bit. Okay, along with the chuck, we have a chuck key. All right, not Chucky, but chuck key. All right, so the chuck key has these teeth around the side that mesh with the chuck, and you can turn this to tighten the bit or loosen the drill bit. Okay. Up here we have a speed adjustment. All right, this is called a variable speed setup. This is the only time you would want to adjust the machine while it's running, because you have to. If you turn this while it's turned off, you can actually damage the variable speed setting. All right, so I'll show you in a few minutes how we can adjust the speed with this. Right along here we have what's called a depth stop. All right, and right now the way it's set, we could drill all the way through our material. All right, but let's say we didn't want to drill all the way through. Okay, I'm going to show you how to set that, and we can set it to stop at a certain point. Okay. All right. So the first thing we're going to do is, we made our push stick the other day on the bandsaw. So I want to drill a hole in the handle so we can hang up the push stick. So in this case, is it super critical where the hole goes?
No.
No. All right. In your case, when you're building a project, usually it is going to matter. So we would normally measure and lay out our lines exactly where we want the hole to go. All right. For today, I'm just going to sketch where I want the hole. All right, make a line, make a little X or a cross. All right. So that's where we know we want the hole to go. All right. If I were just doing this by myself, I would not do the next step, because again, it's not really that critical. But let's say this is a project, let's say this is super important, like the tuning keys on a guitar. We don't want those to be off or out of alignment. So what we would do is, once we've measured out that line, we're going to go to the tool cabinet and grab one of these. Anybody know what this is? Okay, it is a scratch awl, A-W-L. The scratch awl is going to be used to make a little dent right exactly where we want the hole to start. And it's going to help the drill bit find our mark. So I'm going to go right to the middle of the point, give it a little tappy-do. Okay, it's a technical term, tappy-do. So what that just did was it put a little indent right at the X. Okay, and that's going to help the drill bit go exactly where we want it to. All right, the bit I'm going to install is a 3/8 twist bit. All right, this is one of the most common drill bits you guys will use, and they just call them a twist bit because it looks like it's twisted. So this is a very common, standard kind of drills every material drill bit. All right, so we're going to install this. We're going to open the jaws up, and we're going to grab our chuck key and tighten it up. All right, now over on our drill press, we have this little safety feature here on top of the start switch. Okay, we have a little hole which is designed so that you only start the drill press with the chuck key. Why?
Because you can't do the chuck key in.
Okay, yeah, right now, let's just say I'm giving my lesson, I get distracted, and I go to start the drill press. What's going to happen? The chuck key is going to rip off of this chain. It's going to go flying. It might hit somebody. So this is just to remind us all to always take the chuck key out of the chuck before you start the drill press. So we can simply turn it on. And obviously you would not want to do that with the stop button, because if you have to stop in an emergency, you don't want to be looking for the chuck key. All right? Okay, so what I'm going to do is we're going to drill this hole all the way through, and then we'll talk a little bit more about what we can do with some other features. All right, here we go. Excuse my back for a second here. Okay. You guys see how that lifted up a little bit? All right. How can you prevent that?
Slow.
Okay. You could hold down tighter and go a little slower, or you could clamp the piece down. All right. There's a few different ways to avoid that. I'm going to pass this around. You guys can see on the back of the piece, it kind of chipped out a little bit. The reason that happened is because there's a hole right here in the table. How could we prevent that from happening? Okay, get a scrap piece of wood, keep it underneath. That chip out will not happen. So something more important, like a guitar neck, will keep a scrap block of wood under there to prevent that from chipping. So you guys can go check that out. All right. Okay. Some of the other drill bits I wanted to go over with you guys. All right, this one here looks very similar, but it's different because it has a little point at the end. This is called a brad point bit. All right, brad point bits are great for doing super accurate work, and that brad point will help you find the hole exactly where you want to drill it a lot easier, because that point will go right into the mark you made with your awl. So I'm going to take the bit out so you guys can see the difference. We'll pass it around. Okay, so we have the two bits. This one has more of a V shape at the end, and the brad point has a little point at the end. Okay, so you can send that around. All right. Anybody ever see a bit like this? Okay, a couple of you. This is called a Forstner bit. The only reason it's called that is because the guy who invented it, his last name was Forstner. But these are great for making nice, clean, flat-bottomed holes. So whereas the other bit that's going around might make like a V shape at the bottom, this will make a clean, flat hole. All right, so these are great as well. So I'm going to pass that around. Okay. This one here is called a spade bit or paddle bit. All right, spade bit because it looks kind of like a spade shovel, or it kind of resembles a paddle also. These are used in the construction industry a lot. So you frame a house, now you've got to run electrical wires through those studs. They will drill very quick, very rough openings, very rough holes. So would this be a good bit to use for fine woodworking?
No.
No. All right, but we do have a set of them if you need them. I just wanted to share with you guys the difference in the types of bits. All right, so you can pass that around. All right. Does anybody know what this is for? This type of bit. All right. This is called a plug cutter. Anyone want to take a guess what it cuts? Plugs. Very good. Okay. So what we're going to do with this is, let's say we are assembling a project with screws, but we don't want to see the screw heads because they're ugly. All right. What we would do is something we're going to learn later called counter boring, where we'll put the screw below the surface, and then we'll use this plug cutter to cut a wooden plug, either of the same type of wood, so we hide the screw and totally blend it in, or we could use a different color wood to make a contrast, and you have these different colors of woods kind of, in your project. All right, so I'm going to show you guys how to use the plug cutter, and then we'll move on. All right, I just tightened it up by hand. Is that good enough?
No.
No, you always want to use your chuck key. Very good. Tighten that. Okay, and we're going to just cut a plug. Okay, you guys see that? All right. Now what we would do is go and grab a regular screwdriver and go across the grain. We're going to break it out. And now we can take this wooden plug and glue it in place and then sand it flat, and it'll totally hide the screw that we're trying to do. So these plug cutters are found in the tool cage. When the time comes, I'm going to actually demonstrate how to do the whole thing. Okay? Let's talk a little bit about safety. All right? You guys may or may not have noticed I held this long piece of wood out to my left. Would it matter if I held it to the right?
Yes.
All right. Why?
Because it's spinning.
Okay. Will it still make the hole and do its job? Yes, it will. Safety-wise, you always want your board going to the left, because let's just say it hits a knot, something gets caught, and this piece starts to spin. All right, the drill press is spinning in this direction. It's going to swing back and hit what? The machine. Okay, but if it's over to the right, who's going to hit? Yeah, it's going to swing around and hit me. So you always make sure your board is to the left. All right, does that make sense? Okay. Now, let's just say this plug cutter, we don't want to go all the way through, right? And I just estimated where to stop. But let's say I'm doing a bunch of them, and I want to stop at a certain distance. I want to go halfway through. Just so happens this piece has a line right down the board. All right, I can bring my quill down to about where I want to stop, and right over here we have a clamp. It's called a quill clamp. All right, so that's going to hold it in place. Now I can adjust what's called the depth stop. All right, right on the side of the drill press we have a wrench. We can loosen this up and bring these down all the way to this little shelf, and we can tighten this up. All right, you don't have to make it super tight, but just make it tight enough that it's not going to move. Okay, so now when I unlock my quill clamp, just like that, it will stop every time. Okay, what do you guys think you should do if you come over here and this is set and for some reason you're using the wrench and it won't loosen?
Call you.
Please call me over. Okay, a couple years ago somebody said, oh, go to the gym. Don't go to the gym. All right, because what happened was a few years ago, somebody did just that. They said, oh, I'm going to just force it. And they used all the muscle they had and they forced it. And the little casting right here on the side of the drill press broke off. All right, and we're talking about a machine that's been here since the building was built. So I was lucky I was able to find somebody on the internet that had this machine just for parts. It was broken for some other reason, and he actually donated the replacement part to the school. So I was lucky to be able to find it. The reason this broke off is because this whole part here started to turn. Instead of loosening the actual nuts there, the whole piece started to turn and broke the casting. So if it ever gets stuck, please just come and see me. I'll help you get it undone. Okay? So we're going to loosen this back up, move it out of the way. All right, bring that up. Should we do this while it's running? No. Okay, you always want to make sure you're doing all your adjustments, except for what?
Speed.
Speed. Yeah, let's see how fast this thing can go. Take my board away. And by the way, when we were done, we had a bunch of chips on the table. Would it be a good idea to run my hand across the bit while it's running and get the chips out of there? No. All right, you could just blow it away, or you could wait till it stops and then clear your chips away. All right, again, this has to be adjusted while it's running. This particular drill press, for some reason, every once in a while when you're adjusting it, you'll hear like a loud bang, which is not good. I think it's just the pulley getting stuck. I need to work on it. So far, it's been working great today, so we'll see what happens. But there's nothing like dangerous about it. It's just all contained up in here. So you're going to see it gets pretty fast. Right now, it's at its slowest speed. So I'm going to speed it all the way up and bring it all the way down, and then we'll kind of finish up here. All right, here we go. Pretty fast, right? Okay. All right, so no loud bangs this time. That's how it's supposed to work. Okay, so you guys can see it gets pretty fast. For mostly what we're going to do, the best speed is really the slower speed. The faster speeds means more friction, more heat. Now the stuff starts to smoke, burn, stuff like that. Okay? If I've been using this bit all period long, do you think at the end of the period I should take it out of the drill press? No, because you could burn your hand. So I'd rather you just leave the bit in the drill press, let it cool off. All right, right now I know this is cool because we only used it once. We can take it out. It's okay. All right. Some other safety issues with a drill press. How can you get hurt on a drill press? Okay, obviously you put your hand under there. That could be a big problem, right? 5-finger rule does apply. You might see that, my hand might be a little bit closer than 5 inches because the table's a little bit smaller. Sometimes you can't avoid that. All right, but basically keep your hand a good distance away from the bit. What else? What else could be a problem around the drill press? All right, I'm looking around and none of us are gonna have this issue, but people with super long hair, okay, imagine you're looking down at the drill press chuck and your hair is dangling near the chuck. What will happen? Okay, before you even know anything's wrong, your hair is going to get wrapped up in that drill press chuck and it will scalp you. It will pull your whole scalp off of your head. All right, not something pleasant to think about. So people with long hair, how do they avoid that? Hair tie, absolutely. And I always tell my students who have long hair that you might be nervous that you'll forget. And that's okay. I will always be watching. If I see you without a hair tie, I'll come say something. Oh, well, I don't have a hair tie. Fine, I have rubber bands. Okay, there's ways around it. Gentlemen with neckties. Why is a necktie a problem? Okay, the necktie becomes a noose. The necktie becomes a noose. When it gets caught in that drill press chuck, not only is it going to pull you in, but it's going to choke you as it's pulling you in. All right, so in that case, take your tie off, or you could tuck it between the first couple buttons of your shirt so it won't be dangling. Same thing with long necklaces, jewelry, earbuds, okay, nothing. You can't have anything loose, all right? Okay, let's do a quick, oh, there's one more thing, real quick. Let's say we want to drill this tiny piece of wood, all right? Would it be safe to hold it that close with a big cutter like this?
No.
No. So what we can do is go over to the clamp rack. We can grab a wood clamp, which we'll learn how to use a little bit later. All right, and we can clamp this piece just like this. And now I can hold on to the clamp as I'm drilling the hole, and that's much safer, okay? Sometimes we could have a setup where we've got the clamp holding the wood, and then we clamp the clamp to the table, okay? That's also fine. Now, would it ever be safe to have 3 people working on the drill press at one time? No. What about 2? Okay, 2 would be okay, because sometimes you need help holding something while somebody else is working the drill press. That's okay. A lot of times I will be that person to help you, but it's okay if you have somebody else come over and hold something for you. All right? Okay, let's do a little quick review. All right? After you're done tightening the drill bit, what should you do with the chuck key? What's that? Okay, take it out of the chuck, right? We don't leave the chuck key in the chuck. Do we ever want to drill something while the board is up in the air, or do we hold it tightly on the table? Okay, always securely down on the table. Which direction should the long piece of wood go? To the left of the operator, good. Do we use our hand to brush away chips while it's running? No, very good. Okay, we just talked about long hair and neckties, loose clothing are all dangerous, right? Is there ever a time we'd want to touch the bit or the chuck while it's running? No, very good. All right, we said how many people is the most you would want to have? 2, very good. What do we use to start the drill press? Chuck key, good. What about, could we just tighten it by hand and not use the chuck key? No, very good. And what do we always wear? Awesome. Questions? All right, guys, let's go do our test. Great job.